Welcome back to the breadboard. Today we're going to look at a GeeekPi Raspberry Pi Pico programming starter kit using the Raspberry Pi Pico 2040 controller, and this has been sent to me by GeeekPi to review and share with you guys. Today we're just going to look at all the hardware and everything, or in this video. So we're going to open it up, see what we get, see what quality it is, etc. And then we'll follow up with some examples. I've been planning on getting a whole bunch of Arduino type educational videos out, so this would be a great opportunity as we go through those to show some of the Arduino programming working on the Raspberry Pi, as well as Arduinos. Actually, they're all Arduinos technically because of the environment, not because of the physical hardware. But between the Raspberry Pi, the ATmega 328s, and other microcontrollers, to show you how the Arduino environment abstracts everything for you and lets you use the same program on completely different hardware without having to make any real changes. But today, this is all about the Raspberry Pi Pico programming starter kit. So without any further ado, this is the box it came in. Actually, it came in a cardboard box. I've just removed it. It was just a plain cardboard box, but as you can see, it's still wrapped and ready to go. So let's, first things first, get this opened up and have a look what we get with the complete kit. What do we offer? A curriculum system from beginner learning to in-depth using. We use paper teaching examples and detailed video tutorials to get you through Python as well as C++ programs. I'm more of a C programmer when it comes to this kind of thing than a Python programmer, but we will have a look at some of the examples and what we've got. So let's get in here. First things first, a Raspberry Pi Pico MicroPython programming starter kit. GeeekPi.com is where you get support from. And looks like lots of quality pictures in here, as well as example diagrams. All the different components that are probably going to be included in here. So that's good. It's showing us the example code, as well as how to hook them up, which is really nice. It's a little bit extra than what a lot of companies do that just provide a sometimes just a plain PDF on the website. This one looks quite nice. Stepper motor controllers, solar panels, LED displays, oops, etc. So we'll look at that as we go through. Let's just put it there for now. They've got a big bag of bits. We'll open these up in a moment. A GeeekPi pinout board. Anybody that's familiar with Raspberry Pis will be familiar with this kind of layout. Shows you all the pins on the board and what they can be configured to do, straight out of the box basically. Let's go back to the wider. Put that with the book. We have a breadboard. Let's whip that out of there. We'll get rid of the packaging. Got our breadboard. We've got another bag full, looks like a NeoPixel ring, a servo, and bits and pieces for the servo. We have a header cover. This actually came separately, which they're now providing with these kits. This is to clamp down on top of the Raspberry Pi Pico, I think, to make a better connection to the board, perhaps. We'll see. Maybe probably to stop it coming off. So we have that. I'll just put that. Let's have a look over here. We have the Raspberry Pi Pico. And one nice thing here that they've done is they've actually already soldered on the pin strips on either side. I was wondering about that because a lot of the pictures on the web show it without the pins being soldered in. So I was going to be getting back to them saying, hey, you want to make this easy to use, solder the pins on. Looks like they beat me to it, which is nice. Let's just get this out of the bag. Anticipate a lot of the parts in this kit are going to be the same as all the other kits that I've looked at before. So there's the Pi itself. Not to be confused with a Raspberry Pi, mind. We have a whole set of jumpers, two different kinds here. So we have a whole host. We've got there 10, 20, 30, 40 of them, which has got a pin to a socket, which is really nice for connecting to little subboards and things. We have socket to socket for jumping between two different things. Looks like there's 20 of those. We have a whole bunch of the more traditional pin to pin for jumping on the breadboard normally. These have got the round pins on rather than the square DuPont connectors. Different lengths. Have a set of LEDs and rather tiny resistors. That's a little disappointing. The one thing I found with many kits is that the resistors they put in them are too small to make a reliable contact on the breadboard. We'll check out this breadboard. Looks a little nicer quality than past ones, so we'll check that out and see how good it is. Maybe it will make a good contact with the resistors. We have a USB lead for programming. So that's about, what, 2 feet long? What's more important is it's a quality USB lead, not necessarily a long one where you can lose power over the length, especially a lot of the lighter weight ones that have very thin wires inside. We have a 2-line by probably 16 or 20 character display. So that's LCD display but with fixed characters. We have a baseboard with some standoffs and things. Let's get rid of this case for a moment. And in here we have a subboard. Let's just pull this out. Ooh, nice. Let's zoom in a little bit. So what we have here is a board where the Raspberry Pi is going to sit onto it. And then you got all the jumpers board out, all nicely labeled, to go onto the breadboard. And the breadboard would go on there nicely. So that'll go on there, so we'll get that stuck on there in a moment. This looks like it's a backer board for this. Just to stand it off the table a little bit and to insulate pins on the pins on the back. It's all black. So what have we got on this board? We've got some LEDs here, LED 1 through 4, and we have LED 1 through 4 as a header. So we could use the jumpers from here to here to illuminate the LEDs. We've got 4 switches and a beeper. So we've got the beeper here and 4 switches. These little covers are meant to be taken off when you actually, after you've soldered them on and everything. A lot of people leave them on because it quietens them down. They can be very annoying without the little cover on them. That's to protect them from soldering and debris getting into them and stuff. So we have the main strip that the Pico is going to plug into, and we have all of these pins down each side to bring out for jumpers and things like that. On the top we have 5-volt rail, a 3.3 volt rail, and a ground rail. Set of pins so we can jumper easily to the breadboard, etc., etc. So that's all nice and good. I guess the whole thing is powered by the USB connection. So let's get this quickly assembled and we can actually have a look at some of the parts. So first thing we have to do is screw this protective cover on top of the Pico. So that just drops on the top. There's really only one way it can go. And 4 screws come up from the bottom of the board into the 3D printed cover. They may be injection molded by the time you get them. That's 3. One last one to go in. So it's just easier to pick it up before. Don't have to be done up too tight. It's just a little. Okay, so 4. You can see it just provides a little bit of protection and makes it probably easier to plug in and out. Well, something a little more substantial to get a hold of. Push that puppy in. It's good. Now let's stick this board. It's probably got plastic cover on. guess if you want it to be smoky, you can leave the plastic on, but I like to take it off. Make sure you ground yourself after you peeled this, because it is a little staticky. Oh, so there we go. Guess we should put the breadboard on too. So you might be wondering, how do you tell if it's a nice, at least on the face of it, it's a good breadboard? Most of the ones I've seen that are not quite so good. See these sockets here, they are down so you can see it. There are 5 and they're all connected together in a line this way. This side and this side is not connected together. So you have a red and a blue. Usually you put your plus volts on the red side and 0 volts on the blue side. But a lot of not quite so good ones, in my opinion, have this gap between the two not connected. But if I look in here, I can actually see, because it's a transparent case, I can see the connection running through. So these should be connected all the way along. Definitely look to be. And the other thing, which is I know it's a minor thing, but we've got A, B, C, D, E, F, G, H, I, J labeled along here. This side is labeled the same direction, which it should be. Also, it's labeled 1, 2, 3, 4, 5, 6, 7, 8, up to 30. And often some of the not so good boards will label 1 on this side and up to 30 on that way. That way, if you actually have it this way, it still labels left to right on the top one. And the same with these, changing direction. That's not good, because you want to be referring to the same one, no matter which way you have it. So it's the way we're going to put it in. Pin 1 to the top left. Let's peel off the sticker and we'll stick it in. Oh, these also, by the way, you can see it here. Not necessary for this application, but these little nubbies that stick out, they allow you to connect these to other breadboards. So they would click together to make bigger ones. I'll show you something in a second. So we'll stick that on there, and that's that assembled. So that's nice. We'll get that out the way. Let me just grab something and show you. This thing was white a long time ago. I've had this breadboard since I was about 16 or 17 years old. Still going good. Back in the days when they made these things really well. I've got a power supply in the case. I did this when I was an apprentice, and I've built all sorts of different things on here. You can see a few areas where I've kind of melted chips. There's a little grooves melted away in them, one over here, one over here. A few little jumpers, I think, still lingering in here. And it's a bit dusty, but I've been using this thing for years. Quality. But you can see here it's 1, 2, 3, 4, 5, 6 breadboards, and they're actually clicked together using that system that I told you. I also then screwed it all down onto this die cast case. But yeah, just wanted to show you that. Had it for a long time. Okay, so let's continue having a look at what we've got. So I've already mentioned we've got, I'm not going to take them out, but resistors and LEDs. The value, I will take them out because I want to see what value resistors they gave us. Usually you get a lot more resistors in these kits, but in most cases it's not necessary if you're sticking to digital. These are tiny resistors, but they look like they are red, black in the coloring. As I said, they are very small. Yeah, they're red, black, brown. So they're probably 220 ohms. So it's extra digits for precision and things, and tolerance. This is great for driving an LED or something like that. We have a daisy chainable NeoPixel. We have a small servo, micro servo 99 SG90 with a little connection on and some horns for it. So what's in the big bag? We've got 3 bags. Let's just put these to the side and we'll work through them. Okay, we've got a lot of things in this first bag, and they're all in little bags, and all the little bags contained even smaller bags. So I will open them all up and then we'll go over them. Okay, bag 1. What we have in this bag is a temperature humidity sensor. We have a light sensor, LDR, light dependent resistor. We have a vibration sensor. Basically it's a little, can't hear it, but it's a little springy type thing inside a tube. They're isolated and till it detects movement. We have a sound sensor, basically a microphone with an amplifier. We have a 4-digit 7-segment LED display, which is serially connected. It's got a little controller on the back of it. And we have a little 0.9 1-inch OLED display, or 1.3 inch, something like that. Anyway, not very big, but OLED display, which is I2C connected. And then the last thing in that bag was a raindrop sensor. So basically a PCB with 2 sets of tracks that interleave, and if you get raindrops on them, the conductivity changes, and you can pick that up with a little amplifier, and you would have an analog output or something like that. Okay, next bag. This one's got a bunch of different things in. So let's do the same thing. Okay, well, you get a fair few sensors. That's always nice. So, first one up, we have a potentiometer. Not a rotary encoder. It is a potentiometer. It's nice, so testing analog inputs. Next up, we have an ultrasonic transducer. So it pings a sound wave out of one and then receives it on the other, and you can do timing and distance measurements and fun stuff like that. We have a tilt switch, similar to the vibration sensor. We have a 64 LED display in an 8x8 matrix. These things are cool. And it has a controller board on the back. If I lift this off, we have a classic controller here. We'll talk about it when we review this. It talks to this. Again, serially interfaced, the same as this one. This same chip, by the way, will do these 8-digit 7-segment displays we've looked at in other videos. Next up. No, this one requires fully freeing. What we have here is a relay, not a solid state one, it's just a mechanical relay. That's cool. This is great for doing higher level loads. Not high voltage, because whilst the relay may handle 250 volts at 10 amps, the circuit board looks like it probably could as well. But when you're handling this and playing with it, unless you've got this securely mounted in a case to protect you from the mains, you should not be sticking mains on it. We've done videos in the past about that. And the last one out of this little set, it's a Dallas 18B20, which is a temperature sensor. It's a 1-wire temperature sensor, so you talk to it and poll it and get the answer back on the same wire. These are nice little devices. I've used these a lot in the past, and they work very well, and they give you quite accurate temperature readings, but it's only temperature, not humidity. But because they're so small, you can bake them into waterproof connectors and waterproof containers and things like that. Okay, last bag. So I think the exception for what I've seen in most kits so far is having an OLED display. The relay is quite common, but the Dallas as well, and these round NeoPixel lights as well. Those are the 3 things that I think so far stand out. So this is very typical of all of the kits, is this stepper motor, 5-wire, so it's probably got a common and then the 4 wires for driving. Not a bipolar, but it's going to work very similarly. We have the joystick. I have enough of these now that I should be able to make my own little controller. That would be kind of a fun project to do with all of this by combining parts. Okay, next bag. First of all, very similar to a potentiometer. You look at this. You can mistake one for the other quite easily. This one is a rotary encoder, so basically a couple of switches that work in a very special way, and there's also a push button switch in it. So that's good. Rotary encoders are good things. I like playing with those. So we have a gyroscope axis sensor here. So it detects acceleration as well as rotation. It uses a, see if I can see what the part number is, MP something 6050. Lots of drivers, very popular for remote controlled aircraft and all sorts of things. Looks like we have another humidity sensor here. though I could be wrong. GYBME-PM280. This is a Bosch pressure sensor or humidity. It might be humidity, pressure, and temperature in there. You should probably look in the book. I bet you it tells us everything. We have a stepper control board to go with that stepper motor to drive it. So that's good. And last bag, the infamous motion sensor. You provide it power and you've got a pin, and when it detects motion it will provide a logic level change. You've got different modes. You can set the sensitivity and the duration of the change. First thing I notice is that all of these have their jumpers, the connections all soldered in, so there's no soldering required. The LCD display has a serial board already soldered onto the back of it, which is also very nice. The only thing I might think of that is not quite right on here is the resistors. They may be a bit small, but we'll test that. A lot of other kits I've seen, the potentiometer as being standalone and it wouldn't plug in the breadboard without damaging it. They've put this on a daughter board with some properly sized pins, which is nice to see. And the rotary encoder is all soldered up, ready to go as well. I think that's the entire kit that we're looking at there. Just to confirm, this tiny little board is the pressure sensor, so atmospheric pressure. It will also give you typically temperature and humidity as well, because it needs those to do its calculations internally for working out what the air pressure is. So what does the book say that it wants you to start with? Yeah, the LCD display is a 16 line by 16 character by 2 line display, affectionately referred to as an LCD 1602. Guess where they got the numbers from? So this goes through each of the components and gives you a description, which is nice. Shows you little diagrams of the devices. I'm not going to detail read all of this right now. What's inside the breadboard? Oh, quite detailed as well. Nice. Ultrasonic sensor, MPU 6050 accelerometer gyroscope thingy, potentiometer with a diagram. You don't normally get this level of detail in these books, so that's nice to see. It is an educational kit, and it seems to be doing a really good job of teaching you what all of the pieces are. So we've got a MEMS MPU 6050, and it's going into details of how it works as well, which is really nice. Relay module doesn't give us a schematic, but it tells you how to wire it up, which is always nice. Sound sensor, light sensor, bit of info how that works, vibration sensor. This is the 4-digit 7-segment LED display using a TM1637 driver. We've got the rotary encoder, a little bit of a detailed description of how they work, although when we go through that we will do it ourselves as well, maybe in a bit more detail with an oscilloscope and stuff like that. Raindrop sensor, stepper driver, quite a lot about stepper drivers. The actual stepper motor is geared, so it should have quite a lot of torque, maybe not high speed but lots of torque. DHT11 temperature and humidity module, joysticks showing you how they work. Basically it's 2 potentiometers at 90 degrees to each other. Thumbstick module, that's what we just looked at. And now we've got the Pico board, bit of readme before using. So install the Arduino IDE, download MicroPython firmware, setting up phony, LED blinky. Not sure if I'm going to do a bunch of Python code. What I want to do is show you this working with Arduino code. If you're really keen on Python, you can definitely follow the examples in here. I will give you or work through the same functional examples, but I'm going to use the beta 2 and the latest release Arduino IDEs to do some coding. That way, if you've been working on 80 mega 328s, which would be the original Arduino Uno, or other Arduino-like or compatible boards, then you'll be able to take that coding and take it straight to this, which is obviously a lot more powerful microcontroller. Sorry. Bit of a description on how wiring a circuit diagram. how to wiring circuit diagram. A little bit of translation stuff there. It's showing you how to connect things up. I'm going to go through that as well. I'll zoom in a bit closer so you can see the details when I'm videoing it. So that's third project is an OLED 0.96 screen with Pico Basic. So it's a basic example of driving a display, a little alien invaders thing, and try adding a gyroscope to it. Vibration detecting. Maybe we'll do some of these, we'll see. Anyway, so the first thing to do, though, is the classic equivalent of Hello World. So that would be using this board and making one of these LEDs blink on and off. As there is no display on here right now, unless I plug one in. Now it looks like these LEDs have got resistors in there. I can't quite tell what value they are. Not sure if that's an O1B or something else. Guess I can always measure them. I'm curious as to whether they're 5-volt compatible or not. But they are, they're 1K. So 1K resistor in series with each LED. Yep. And the LEDs are probably got a diode test and they probably will light up. Yep. Don't know if you can see that very well. Zoom in. So blue LEDs. And they've got a common ground, so you drive them with a positive. Which is good for the beginner because 1 equals on, 0 equals off, right? Makes it easy to remember. Okay, so we have our kit. Get that up out the way. We want to put let's zoom in a little bit. Here's our board. We don't need resistors for this. We will need some jumpers though. Here is our USB connection, so we have to connect that to a computer. Now, thing to remember with the, well, I say remember, you may never have looked at it yet to know this. See what I mean about the noise? A little quieter for the moment. I wouldn't necessarily call it a design flaw, but common mistake for beginners as well, for sure, is the buzzer has a driver right here. It's driven from that pin. So if I touch that pin now, it's going to start beeping at me again. Like that. And that's because an input of a MOSFET is very, very high impedance. So a bit of stray capacitance or whatever will basically turn it on. If I put my finger here on the ground and touch it again, see, I can turn it off. Go to 3.3 volts. I can turn it hard on. And it will stay that way. Because an input to a FET is like a capacitor. So there it is off. So the easiest thing for the moment, if I want to make sure it stays quiet, is to put a jumper from there to ground. Anyway, that's it all plugged in, ready to go. As you can see, there actually is an LED on the Pico board. I'm trying to remember what pin it's actually connected to. But obviously with all this on here, the one that's built into this is going to be covered up. So we'll need to take a jumper. Usually on an Arduino it's GPIO 13. So maybe GP13 on here will also do the same thing. We'll take a jumper and we'll put it across to one of these LEDs and see if it lights up when we load a blink sketch and send it over to it. Anyway, first things first, we got to get drivers and an Arduino IDE up and running. So it's been a while since I've updated the ones on here. But let's go have a look. Arduino IDE. I'm going to go to arduino.cc, and the beta one right now is, where is it? There you go. Beta 12. So let's just download the later version. All right, also download the latest. Arduino 1.8.16. So again, Windows 7 and newer. And we'll just download that. So anybody who's been using Arduino IDEs before or programming Arduinos, doesn't matter whether it's an Arduino IDE, whether you're using Platform IO, or whether you're using the official ATmega IDE based on Microsoft Visual Studio, usually programming an Arduino ATmega 328 type board, you would use a COM port, whatever your computer happens to set it up to send the program over. When you're programming a Pico board, one of these Raspberry Pi ones, it's the same as an ST Micro and other ones, you're actually dumping a file to a folder that gets picked up by the firmware that's built into the microcontroller. So in here, let's get rid of this project, start with a new one. I don't think it's got the board manager loaded for it. Let's go to board manager and we'll type in here Pico, right? So it's not in, it can tell us here it's not, it's the embedded one. It's not installed yet, Raspberry Pi Pico. So we'll load that in. Now if you go to file, right, we've got the Raspberry Pi Pico. It says it's not connected, but remember what I said. It doesn't need a COM port to be connected. So let's download or pick the basic Blink sketch. All right, again, it jumps up another one open. And what we've got here is setup, pin mode, LED built in, and we don't know what pin number that is. And then it has a 1 second oscillating blink. So let's just hit compile. It should work for the Raspberry Pi Pico. There we go, compilation. That was the very first time I've used compile on it. So obviously the sketch is 13K long, but we've got an awful lot more space than that. Let me make the font bigger if I can. That's better. Back to what it was. I must have caught the other one. So that makes it more readable for you. So theoretically, because the Arduino IDE uses a folder, I think the sketch is going to be able to, or the compiler is going to be able to find it and just do it. So let's just hit upload. This is the first time I'm trying to upload anything to this. It'll give me an error if it can't find it. Compilation complete, upload complete. So it did it. So if we look at the board, there is a little, you can see it just in there, blinking away, 1 second interval. So let's see if we can find out what pin it's on, and we'll get it to an outside LED just so we can see it a little better. Okay, a few moments later, just checked on the raspberrypi.org website, and the built-in LED is on pin 25 of the microcontroller. That pin is not brought out to this pin header on the Raspberry Pi board, so we can't make it blink the LED. Not with that sketch. We'll have to modify it, and that is actually relatively easy. So we go back here. Instead of LED built in, we'll just change this right here, and we'll pick just 0. And we have to reboot the Pi with the button pressed. Now it's running a code. If I try and, let's just do it right now with this board. If I try and compile and upload this right now, it'll compile okay, but it will complain when it tries to output to the board. I'm thinking it should. Yeah, failed to upload. Now if I power the board off by disconnecting the power, press and hold the button. So I've got the power off, press and hold that button and reconnect the power. It'll come back on. You heard it hopefully coming into the PC. I can let go of the button. Now if I do the upload again, let's go back to that screen. It should work this time. I'll say pile and upload. Now it should upload it again. Only this time we should see this LED, hopefully. Of course, one of the whole things about this is if you look at this code, I've set pin mode 0 to output, perfect, but I didn't change these two to say 0. So let me just make a constant up here for the LED, and I'll show you how to set this up properly. Define LED pin 0. So now we just use this constant of LED pin for everything. So we'll change this to say LED pin, and this to say LED pin, and this to say LED pin. And theoretically now that should work. So let's just reboot again. And we'll upload it and see if it actually starts it working. USB connector is quite tight. Okay, let's reset. Got that on the screen. I've seen it compile a couple of times. I'm sure you'd rather see the... Hopefully I got all this correct this time. It's really my first time using this with an Arduino environment. There we go. Perfect. So LED pin, we just tell it it's pin 0, which is GP 0 on the board. And there it is blinking away. So, as you can see, Raspberry Pi Pico perfectly working well with an Arduino IDE. This is a IDE 2.0 beta 12. If you're not comfortable running beta software, let's quickly just copy this whole program and we'll get rid of that. We'll load up the regular Arduino IDE. It's the latest one. I did just update that. And we will load up the blink sketch. Alright, now we want the blink sketch, which we've got. Now it's exactly the same sketch. So if I paste my edited code, slightly shorter, but it's the same thing. A lot more comments on the other one. So this is exactly the same as the code from before. In here, if I do compile, done compiling, no error. So let's now just simply say upload. I haven't picked a COM port. So look at this. The board is the Raspberry Pi Pico. There are no COM ports picked, although I could pick one. There is one set up there right now. But we're not going to set anything, and we'll just go upload. It should upload. It shouldn't actually change on the screen. I'll tell you when it's there. Right now we're looking at the board. Might error out because I didn't reset the board. Let's do that again. I think a USB cable with a switch in it would be nice. Okay. That folder that's popping up, by the way, on my screen, that's what pops up when the Pico presents part of its memory as a USB stick, effectively. And this is where you dump the program to. So let's try that again. Should work this time. Yep, there we go. Still going. Oh, sorry, looking in the wrong place. Done uploading, says it right there. So, how do we know this is actually working properly? Well, let's just do something a little bit more fun. We'll use GPIO pin 1, and we'll connect it to LED 2. Okay. And we will modify the sketch so that we can have, whoops, LED pin 1 is on 0. Now we'll make this easier. LED 1 is on 1. And we will make LED pin 0 on pin 0. This is just a definition. Alright, so this is using LED pin 1. So now if I actually take this line and just duplicate it, and this one. Make this top to 0. And we'll make that low, and this one high. So now what should happen is it should alternate between these two LEDs on the board, LED 1 and LED 2. Very simple. We'll also make it do it a little faster. Why not? Just so you know, we are really doing a very simple upload to this. I'm going to pull the power from the other end this time. So we've got to reset it into programming mode, or DFU mode, whatever you want to call it. Put the power back in. There's our little pop-up screen, so we know we're in the right mode. Now we'll compile this. I think I've got everything correct. Low, low, high, high. Half a second delay. And we'll say compile and upload. So it's compiling. Compiled, no problem. Now it's updating. And it's done. And look at the board. You can see quite happily right here it's flicking nicely between the two. Perfect. So, okay. This, as I said, is the Raspberry Pi Pico starter kit. So zoom out. Twink, twink. From GeeekPi. And it comes with a great number of goodies to try out different circuits and everything else. I'm going to stop the video here because it's probably already gone on longer than I wanted it to. I wanted to have a detailed run through all the parts and show you how to get your program going. Might look at doing MicroPython in different videos, but in this one I want to use the Arduino IDE so that it's familiar with a lot more people initially. Plus, I don't particularly like Python, but you know, that's my preference. Not yours. So, what else to do? Let's look at the site, see how much it is. Let's just close this down, bring up this. So you can get it from Amazon.com, Amazon.Japan, Amazon.co.uk, Amazon.ca, or you can buy it, I think, directly from them. That's the picture with all the kit. They got documentation and things on the 52Pi wiki site. So it's wiki.52pi.com. Raspberry Pi Pico MicroPython Programming Sensor Kit. As you can see, it's way more than just MicroPython. That's just the way they sell the kit, and a lot of the examples in the book are from MicroPython or using MicroPython. We will go through some of the examples in here, but maybe we'll just convert them to Arduino code as well to try them both ways. I do have another few Raspberry Pi Picos, which I bought myself, and so I'll put some pin header strip on one of them. So rather than keep having to reset the way that the Pico works, because I think when you run Python, it's interpreted. I think you need to upload like a runtime package or something to the board. That's okay, but I don't want to keep doing it on the same one, so I might end up using two of them and just switch them in the socket. So pricing. This is the kit that we got. You can see here. Raspberry Pi Pico in the middle. And we've got all of these parts with it. A bunch of information. So $69.99. So $70 US. If I go to Canada, we're looking at $90. Plus $20 shipping and import duties. That must be coming from the US at the moment. Oh no, sold by GeeekPi and fulfilled by Amazon from outside of Canada. Okay. So it's still going to cost you, so actually it's going to cost you about $100, $110. That's not too bad as far as kits go. The parts fit much, much better than I've seen on other kits. Oh, we didn't try that resistor yet. We'll do that in a minute. Let's not forget. You can also, I'll provide links to other Amazon sites as well in the description. There'll be affiliate links Won't cost you any more, but it'll help the channel if you buy through the link. Let's just get this back on the board right there. I'm going to grab one of these resistors. If you just pull them out of the tape, if you look at these resistors, they're on tape. If you just pull it out, you're going to get glue on the end of the resistor. So either clean them with an alcohol wipe or a little blade or something to get that glue off, because you don't want it getting inside your connectors. I'm just scraping it off here. Okay, anyway, what I want to try here is to see how well it will. Okay, it's actually gripping that. That's good. So this is a much better quality breadboard. On the other ones, if I put that in there and tip the breadboard upside down, it would have fallen out. This one, it's a good breadboard, so I like that. Can't lift the breadboard up with the grip, but then again, you don't want it that tight. But that fits nicely. What else can we have for a bit of fun? I'll tell you what. Let's just stick. I know it will be annoying, but just showing you driving the beeper. So I'm going to very quickly do a quick program just to show you something else on here, how easy it is. I won't make you watch me writing it, but I'll be right back. That's now sent to the board, so let's go look at the board. Here we go. And you can see the light flashing. I've got the GPIO 0 connected to LED 1. I've got GPIO 1 connected to the beeper, and I've got GPIO 2 connected to the switch 1, which is the first switch, which is this one right here. So you can see it flashing about on a 1 second cycle on and off. If I press the button, it just beeped for 1 second, and now you can see it flashing at a ½ second interval. If I let go of the button, it'll go back to the 1 second, but no beeping. I press the button. It beeps for a second, and then it will continue without any more beeping, as long as I hold the button. That could be a toggle switch or a sensor or anything. Then I'll let go again. So anything that will change that input from a 1 to a 0 will trip it into fast flash mode, and it will beep the beeper for one quick beep. So that is the little example all done for now. I'm going to finish it there. My conclusions on this is a very nice little kit. Price is not too bad, and I think it might make a great Christmas present for somebody. It's using one of the later Raspberry Pi controllers that have come out. This is their first foray into a microcontroller versus a microprocessor, which is what the other Raspberry Pis have in them. This is the Raspberry Pico, but it's still got an ARM Cortex, and it's still running very, very fast compared to other microcontrollers. I mean, it's running pretty much as fast as an ESP 32 kind of speeds. They run at like 80 or 160 megs. Anyway, that's it. So if you liked the video, give us a thumbs up. If you didn't, then don't. And I will see you in the next one real soon. Bye for now.